Hello friends, good morning. Today we are going to discuss about aliphatic nucleophilic substitution reactions, and this is our second lecture on this. In last lecture we discussed about a basic concept about nucleophilic substitution reactions. So in case of aliphatic nucleophilic substitution reaction and aromatic nucleophilic substitution reaction, somewhat difference for that. Just start about aliphatic nucleophilic substitution reaction. So mostly in case of aliphatic nucleophilic substitution reaction, SN1 reaction that we have already so many times studied about this, and SN2 reaction are also there. So SN1 reaction is nucleophilic substitution reaction unimolecular, and SN2 means substitution reaction, this nucleophilic substitution reaction bimolecular. So let's start with SN1 reaction. That is a nucleophilic substitution reaction unimolecular. Suppose we have a reaction, general reaction, or we'll take one example about it. Suppose we have this tertiary butyl bromide, right? Tertiary butyl bromide. This is our substrate, tertiary butyl bromide molecule. And when this tertiary butyl bromide molecule reacted with OH, alcohol, means we have to do alkaline hydrolysis of tertiary butyl bromide molecule. We have to do alkaline hydrolysis. Alkaline hydrolysis of tertiary butyl bromide molecule. Okay, so this is OH. So this OH minus will act as a nucleophile. Now this nucleophile is having a negative charge, so it is a negative nucleophile. In last lecture we have already discussed that nucleophile means it may contain a negative charge or it may be neutral. Okay, so this nucleophile is having a negative charge. Now when this OH minus is reacted with this tertiary butyl bromide, we have this nucleophile, that is OH minus, and this is our substrate. Now the reaction will take place and we will get a product, that is MECME, and this Br is replaced by or substituted by this OH minus. Now this is our product, that is tertiary butyl or butanol. Okay, we are getting this product. Now this is a SN1 type of reaction. In case of SN1 type of reaction, you will see it is a two-step reaction. It is a two-step reaction, and it will be discussed in a mechanism. Let's see its mechanism. We are having this substrate molecule, and after attack of this nucleophile, we are getting this substituted product. That is nucleophilic substitution takes place. This is a nucleophile, and nucleophilic substitution on this carbon by replacing this bromide molecule takes place, and we are getting this alcohol. So see, in case of SN1 reaction, it is a two-step reaction, right? So step 1, let's see about mechanism. Step 1, that is formation of carbocation. Formation of carbocation. So firstly we have this molecule, that is tertiary butyl bromide. Now see, reversible type of reaction. This bromine, which is a leaving group, is eliminated out by taking these 2 electrons, right, from this bond towards with it. That is, as it is a highly electronegative, it will take up that both electrons from this bond. So this carbon, central carbon, will become electron deficient, means it is with positive charge, means formation of carbocation takes place. That we are getting tertiary butyl carbocation, right? And leaving group is Br minus is eliminated out. That is a leaving group. Now we have this tertiary butyl carbocation. Okay, this is the first step, that is formation of carbocation takes place. Now the second step is step 2, that is addition of nucleophile. So in our reaction we have this OH minus as a nucleophile. So in this carbocation, that is tertiary butyl carbocation, we have, on addition of this nucleophile, you will get a product, that is substituted product, and here is the OH, that is a substitution product. Now see, the first step is a slow step and second step is a fast step. So the first step is a slow step, and in first step tertiary butyl carbocation formation takes place. So as it is a slow step, it is a rate determining step. Means formation of carbocation is a rate determining step, and as it is a rate determining step, in this step only there is a substrate is taking part, and there is no need of or not a role of any nucleophile in this step. This the rate of this reaction, rate of SN1 type of reaction, is only depend on concentration of substrate and not on the concentration of nucleophile. So it is a first order reaction. SN1 reaction, in case of SN1 reaction, only the rate is depend on concentration of substrate and not on the nucleophile. So it is a first order reaction. This is an important point. So first step is a formation of carbocation and second step is a attack of nucleophile. So in case of first step, it is a slow step and formation of carbocation takes place. In case of this reaction, there is attack of nucleophile. In case of first step, there is formation of carbocation takes place, but in case of a second step, there is attack of nucleophile takes place. So this attack may be takes place from front side or from the back side. So in case of stereochemistry, the inversion of configuration takes place, or if it is a stable carbocation formation takes place, then retention of configuration is also possible. So there is a racemic mixture formation takes place. So in case of a SN1 type of reaction, racemization, mostly racemization takes place, but there are some conditions for the racemization or retention of configuration or inversion of configuration. Let's see in case of kinetics of that and stereochemistry in detail. So in case of a kinetics, we already discussed it. It is a first order reaction, right? It is a first order reaction, right? Because in case of this SN1 reaction, the rate is directly proportional to concentration of substrate, right? The rate is directly proportional to concentration of substrate and not there is any role of nucleophile, means concentration of nucleophile. It is a first order reaction. Means the rate of SN1 reaction depends only on concentration of substrate and it is independent on concentration of nucleophile or the attacking nucleophile. So thus kinetics says that it is a very strong evidence for the first order reaction of SN1 reaction. So SN1 reaction is first order reaction, that is rate is only depend on concentration of substrate. Then in case of stereochemistry, see, in first step there is a formation of carbocation takes place. When we have a substrate, then we have a nucleophile, and in case of a product, first step is substrate, that is our methyl group is there and Br was there. So formation of carbocation takes place and leaving group is eliminated out, and in case of a second step, this positively charged species carbocation get attacked with this nucleophile and we are getting the product. Maybe attack takes place from front side, that is, or maybe from the back side of this carbocation, right? So we will get two stereoisomers. Maybe as the attack is from front side, that is ज्या बाजूने Br eliminate झाला आहे, the leaving group is eliminated from that side. If attack is taken from that side, then you will get retention of configuration, right? Retention of configuration. And if attack is taken from back side, then it will give you inversion of configuration. So in this case, as carbocation is a stable species, now if the carbocation is a stable species, suppose we have this methyl group, right? So they are electron donating groups and they can be easily stabilized as positive charge. So this is a more stable carbocation is there. So as formation of carbocation is more stable, the attack of nucleophile, it get more time to attack. So that attack of nucleophile maybe takes place from front side or from the back side. So there is a retention of configuration as well as same possibility for inversion of configuration. So you will get 50-50% product. That is called as a racemic mixture. So mostly it is said that the SN1 reaction gives you formation of racemic mixture, but there are some conditions which can changes this condition or racemic mixture formation. So first one is, if there is a formation of carbocation is stable. Suppose we have pH C, here Me, Cl, H. We have this phenyl group which is a highly electron donating group. So in case of SN1 reaction, first step will be slow step, which is the rate determining step, right? So it will give you elimination of Cl. Leaving group is Cl. Cl minus is eliminated out, right? So after elimination of this leaving group, formation of carbocation takes place. Now you can see this pH will make a stable carbocation. Suppose we have this carbocation formation takes place. Now this carbocation is stable carbocation because this Me group is electron donating group, this pH is electron donating group, means they are showing a plus I effect. So they are this formation of this carbocation, this is highly stable carbocation. Now it has that much stability that attack of nucleophile, attacking nucleophile may be OH minus, maybe takes place from back side or maybe from the front side, right? So in case of this compound, there is a leads to the formation of stabilized benzylic acid carbocation. This is a benzylic carbocation, not benzylic acid, benzylic carbocation, right? Phenyl ringच्या बाजूच्या कार्बनवरती पॉझिटिव्ह चार्ज आहे, कार्बोकॅटायन आहे, सो इट इज अ बेन्झिलिक कार्बोकॅटायन. ओके, मीन्स रेसिमायझेशन म्हणजे अटॅक व्हायला दोन्ही बाजूने, बॅक साईड अटॅक इज ऑल्सो प्रिफरेबल अँड फ्रंट साईड अटॅक इज ऑल्सो प्रिफरेबल. सो इट विल गिव्ह यू 50% from, if there is a back side attack, then it will give you inversion of configuration, right? And if it's front side attack, then retention of configuration, means 50-50%. So if there is a stabilized carbocation formation takes place in a first step, then in the second step the attack of nucleophile may be possible from front side as well as from back side. So in case of this benzylic carbocation, you will get 98% racemization, means 98% you will get racemic product and remaining 2% will be a different product. So 98% racemization is possible as there is a formation of stable carbocation formation takes place. But suppose if we have a different example like this, that is C6H13 CHCl and Me. Okay, if we have this group, this C6H13 is electron donating group, but suppose in case of this reaction the first step will be slow step, that is a rate determining step. Suppose we are doing SN1 reaction, then Cl will be eliminated out as minus Cl, right, leaving group. So we will get C6H13 CHMe carbocation. So compared to this carbocation, in case of this carbocation, this benzyl carbocation is more stable because there is a more electron donating group, and so there is a resonance possible, but not such a condition in this carbocation. So it will give you only 34% racemization. Okay, only 34% racemization and remaining all percentage for the inversion of configuration. Inversion of configuration. Why? Because if there is a stable carbocation formation takes place, then both sides attack is possible. But now this carbocation is not that much stable, so only 34% racemization will be, and remaining all will be just only backside attack is possible. Okay, and inversion of configuration takes place. Backside attack झाला म्हणजे काय होणार, inversion of configuration. जर front side attack पण झाला असता तर काय झालं असतं, racemization मिळालं असतं. पण ह्याची स्टॅबिलिटी तितकी जास्त नाही आहे की तो तेवढा वेळ देऊ शकतो बोथ अटॅकसाठी. सो जस्ट जेव्हा काय होणार आहे, इलिमिनेटिंग म्हणजे लिव्हिंग ग्रुप इलिमिनेट होणार आहे, तेव्हाच मोर प्रिफरेबल हा जो असणार आहे तो बॅक साईड अटॅक करणार आहे आणि तुम्हाला इन्व्हर्जन ऑफ कॉन्फिगरेशन मिळणार आहे. जर स्टेबल कार्बोकॅटन फॉर्म होत असेल तर बोथ साईड अटॅक पॉसिबल असतो अँड यू विल गेट अ मोर पर्सेंटेज ऑफ रेसिमिक मिक्सचर, राईट. But in this case there is not that much stable carbocation formation takes place, so racemization percentage will be lower and inversion of configuration percentage will be higher. This is an important point. about nucleophile and stability of carbocation. Then in case of a solvent also affect in racemization and all. So let's see about that. Suppose we have a different solvents, means polar nucleophilic solvent and all. So suppose we have a water as well as a acetone. So water is a more nucleophilic. Suppose we have a condition like this, pH, C, Cl, amine and hydrogen. Only one example. So after the formation of nucleophile, suppose we have acetone and water, mixture of acetone and water. So water is a more nucleophilic, acetone. Suppose we have 80% acetone, mixture of 80% acetone and 20% water. Means the less nucleophilic is acetone, which is in a higher concentration. And the second condition, this is the first condition. In second condition, we are taking just water, which is a higher nucleophilic. 100% water we are taking. Now न्यूक्लिओफिलिसिटी जास्त आहे म्हणजे काय, CL ग्रुप बाहेर पडेपर्यंत म्हणजे लिव्हिंग ग्रुप बाहेर पडेपर्यंतच काय करणार आहे, जो न्यूक्लिओफाईल आहे तो अटॅक करायला बघणार आहे, राईट, बॅक साईडने. मग जर हायर न्यूक्लिओफिलिक ग्रुप असेल, सॉल्व्हंट सिस्टम म्हणजे जर सॉल्व्होलिसिस रिॲक्शन बघितली, सॉल्व्होलिसिस मीन्स व्हॉट, सॉल्व्होलिसिस मीन्स वेन solvent is only attacking as, solvent is acting as an nucleophile, when solvent is acting as an nucleophile, then only म्हणजे जो सॉल्व्हंट असणार त्याच्यातलाच एक पार्ट असणार तो काय ॲज अ न्यूक्लिओफाईल म्हणून काम करणार आहे. ह्याच्यामधला जर वॉटर मॉलिक्यूलमधला जो OH आहे तो जर न्यूक्लिओफाईल म्हणून काम करणार असेल तर काय होणार आहे, याच्यामध्ये कॉन्सन्ट्रेशन ऑफ वॉटर काय कमी आणि सेकंड कंडिशनमध्ये काय 100% स्ट्रॉंग न्यूक्लिओफाईल वॉटर आहे. सो जेव्हा ॲसिडोन असणार आहे तेव्हा न्यूक्लिओफिलिक अटॅक काय असणार आहे, लेस प्रिफरेबल असणार आहे. जेव्हा 80-20 प्रपोर्शनमध्ये असणार आहे, सो न्यूक्लिओफिलिक अटॅक ऑफ वॉटर विल बी लेस प्रिफरेबल. म्हणजेच काय होणार आहे, जर जास्त कॉन्सन्ट्रेशनचं वॉटर असलं असतं म्हणजे 100% न्यूक्लिओफिलिक असलं असतं तर काय असणार असतं की इन्व्हर्जन ऑफ कॉन्फिगरेशन विल बी प्रिफरेबल. वाय, बिकॉज बॅक साईड अटॅक विल बी प्रिफरेबल. Means when there is 100% water, then you will get a 80%. Okay. Inversion of configuration. When there is 100% water, then 80% inversion of configuration. म्हणजे backside attackers काय असणार आहे, preferable असणार आहे. And when there is 80% acetone and 20% water, then you will get somewhat 98% racemization. Racemization means attack from both sides is possible now. Backside attack as well as front side attack, both attack are possible because there is acetone is 80% and nucleophile, that is a strong attacking nucleophile, is only 20%. So firstly there is elimination of Cl will takes place, and in second step means carbocation formation takes place in the first step, and in the second step the attacking nucleophile will be attacked, and it will be possible from both back side as well as front side. So at 98% racemization means both products are possible. But in case of water, when it is 100% water, only there is 80% inversion of configuration takes place, right? So this is the effect of solvent in case of a solvolysis reaction. Okay. Then in case of ion pair, means which type of ion pair are forming, it is also affect the SN1 reaction, rate of SN1 reaction. See, suppose in case of Rx, we have a substrate molecule, X is a living group, right? And R is our substrate, where X is a living group. Suppose we have R plus and X minus, this type of condition. Then second condition will be R plus, X minus. This is second condition. And suppose R plus X minus. These three conditions are different, right? First, second and third. In case of a first condition, first is an intimate contact or tight ion pair, means R plus and minus ions are tightly bounded to each other. Then second solvent is a separating ion pair, means both first and R plus and X minus are separated by effect, means solvent effect. And third is a dissociate ion pair. Third is a dissociated, totally dissociated, plus and minus both ions are totally dissociated. In case of first condition, both are in intimate contact, right? Both are joined together Then in case of a second, they are separated by a solvent effect, means both are little bit separated, x plus and R plus and X minus. And third are totally separated, that is both cation and anion totally separated. So in case of this first, second and third, in case of first and second, X minus is called as an counter ion. Here this X minus, in this both case, we can call it as counter ion. Okay, counter ion, which are closely related to this R plus, which are closely bonded with this R plus. And in case of the reaction in which the intimate ion pair is recombines to give the original substrate, means there is a chance after separation of this X minus, there is a chance to reattach this X minus to R plus. म्हणजे एकदा हे R X minus सेपरेट झाले, हे काय X minus काय लिव्हिंग ग्रुप आहे, लिव्हिंग ग्रुप याच्यापासून सेपरेट झाले, R प्लस पासून सेपरेट झाले, त्याच्यानंतर पुन्हा पॉसिबिलिटी काय असते की ते लगेच पुन्हा त्यांना जॉईन होऊ शकतात इन केस ऑफ दिस काउंटर आयन ऑर वेन दे आर इन इंटिमेट कॉन्टॅक्ट विथ इच अदर. सो there is again formation of original substrate. So it will called as a internal return. You can say it is a internal return. The reaction product can be formed by the attack of nucleophile at any stage. So in reaction, the intimate ion first is likely to lead the inversion as the attack takes place from the backside. Means firstly, in case of this first, X minus is closely attached to this R plus. म्हणजे जेव्हा हा X minus बाहेर पडायला काय करणार आहे, प्रॉब्लेमॅटिक आहे थोडा. वाय, बिकॉज दे आर क्लोजली बाउंडेड टू इच अदर. म्हणजे जो काही न्यूक्लिओफाईल आहे तो काय करणार आहे, बॅक साईड अटॅकच प्रिफर करणार आहे, कारण फ्रंट साईडला X मायनस आहे. सेकंड कंडिशनमध्ये पण सेम आहे की फ्रंट साईडला कारण जॉईन असल्यामुळे, फ्रंट साईडला X मायनस असल्यामुळे, लिव्हिंग ग्रुप असल्यामुळे न्यूक्लिओफाईल प्रिफर करणार आहे बॅक साईड अटॅक. पण याच्यापेक्षा कमी याच्यामध्ये असणार, कारण हा लेसली बाउंडेड आहे. आणि याच्यामध्ये काय आहे की हा लूजली बाउंडेड आहे, म्हणजे जस्ट बाउंडेडच नाही आहे, सेपरेट आयन्स फॉर्म झालेत. सो देर इज अ पॉसिबिलिटी ऑफ बोथ साईड अटॅक, राईट. फ्रॉम फ्रंट साईड न्यूक्लियोफिलिक अटॅक इज ऑल्सो पॉसिबल अँड बॅक साईड ऑल्सो पॉसिबल. सो ॲज पर द रिॲक्टिव्हिटी यू कॅन से दॅट अटॅक ऑफ सेकंड मोर लाईटली फ्रॉम बॅक साईड. फर्स्टमध्ये काय असणार आहे, बॅक साईड अटॅकच प्रिफरेबल असणार आहे, त्याच्यापेक्षा जरा कमी काय असणार आहे, सेकंडमध्ये असणार आहे. अँड but not racemization will takes place, and where attack of third can be takes place from both equal side, means front side as well as back side. Thus we can proceed from first to third. The degree of racemization increases. म्हणजे पहिल्यांदाच काय असणार आहे, फर्स्ट कंडिशनमध्ये तुम्हाला इन्व्हर्जनच मिळणार आहे, इन्व्हर्जन ऑफ कॉन्फिगरेशन. वाय, बिकॉज न्यूक्लियोफाईल विल ओनली अटॅक फ्रॉम बॅक साईड, कारण की हा ऑलरेडी अटॅच आहे. सेकंडमध्ये काय असणार आहे, मोस्टली इन्व्हर्जन काय करणार आहे, प्रिफर करणार आहे, कारण की हा फ्रंट साईडने काय लाईटली अटॅक झालेला आहे. सो इन्व्हर्जन प्रिफरेबल असणार आहे. बट इन केस ऑफ दिस थर्ड, देर इज नो एनी बॉन्डेड विथ एक्स मायनस, सो इट विल गिव्ह यू रेसिमायझेशन. वाय, बिकॉज बोथ साईड अटॅक इज पॉसिबल. सो डिग्री ऑफ रेसिमायझेशन काय होणार, इथे डिग्री ऑफ रेसिमायझेशन काय असणार आहे, मिनिमम असणार आहे. ह्याच्यामध्ये पण मिनिमम असणार आहे, पण याच्यापेक्षा जास्त असणार आहे, राईट. आणि याच्यामध्ये काय असणार आहे, हाय असणार आहे. ओके. So degree of racemization will increases from first, second to third. This is an important point about ion pair. Okay, जर highly intimate pair असेल R plus X minus मध्ये only backward attack possible असणार आहे, म्हणजे तुम्हाला inversion of configuration मिळणार आहे. सेकंड कंडिशन जेव्हा काय असणार आहे, ते एकमेकाला अटॅच आहेत पण सॉल्व्होलिसिस सॉल्व्हंट इफेक्ट आहे, म्हणजे जस्ट X प्लस अँड मायनस सेपरेट आहेत. तर काय असणार आहे की बॅक साईड अटॅक पॉसिबल असणार, कारण अजूनही हा X मायनस याच्या काय आहे, बाउंडेड कॉन्टॅक्टमध्ये आहे. आणि जर रेसिमायझेशन कधी असेल, जेव्हा थर्ड टाईपची पेअर असेल, म्हणजे सॉल्व्हंटने दोन्ही कॅटायन आणि आयन काय झालेत, पूर्णपणे सेपरेट झालेत, तेव्हा अटॅक ऑफ न्यूक्लिओफाईल मे बी फ्रॉम फ्रंट साईड इज ऑल्सो पॉसिबल और बॅक साईड इज ऑल्सो पॉसिबल. सो यू विल गेट रेसिमायझेशन. So degree of racemization will increases from first, second to third. Okay. Then third point is formation of rearranged product. In case of carbocation, okay, rearranged product means, in case of carbocation C, carbocation is always try to become a more stable. So first, if we have this condition Me, CH double bond CH2 and Cl. Okay, Cl we have. In presence of this ethanol, it act as a nucleophile. So firstly, SN1 रिॲक्शन असल्यानंतर काय होणार आहे, फर्स्ट स्टेप म्हणजे काय की हा जो न्यूक्लिओफाईल आहे तो काय करायला बाहेर जायला बघणार आहे विथ इट्स इलेक्ट्रॉन पेअर. सो यू विल गेट Me. As this nucleophile will living group is eliminated out, that is Cl minus will eliminate out, this carbon will having a positive charge now, and species will be CH double bond CH2, right? So you will get this compound. Now this may be stabilized by resonance. See how resonating structure will be there. This electrons from this, it will shifted here. So here will be a double bond and positive charge will be on this carbon. So you will get species like this Me, CH, double bond CH, CH2, positive charge, right? So this is a resonating structure for this carbocation. Now the product may be possible from this carbocation also or from this carbocation also, but the most stable carbocation will be give you high yield of product. सो जर याच्यावरती अटॅक झाला तर प्रोडक्ट काय मिळणार आहे, Me, CH, CH double bond CH2, and from this carbocation you will get Me, CH double bond CH, CH2, OH. These both products are possible. Now see, SN1 रिॲक्शन जेव्हा असेल तेव्हाच काय असणार आहे, कार्बोकेटाइन फॉर्म होणार आहे फर्स्ट स्टेपमध्ये, आणि सेकंड स्टेपमध्ये न्यूक्लिओफिलिक अटॅक होतो. म्हणजे जेव्हा फर्स्ट स्टेप होणार आहे तेव्हा तुम्हाला काय मिळणार आहे, चान्स मिळणार आहे या कार्बोकेटाइनला स्टॅबिलाइज होण्यासाठी. SN2 रिॲक्शनमध्ये तशी कंडिशन पॉसिबल नसते, डायरेक्टली बॅक साईड अटॅक होतो आणि लिव्हिंग ग्रुप फ्रंट साईडने बाहेर पडतो. सो ओनली इन केस ऑफ SN1 रिॲक्शन देर इज अ पॉसिबिलिटी ऑफ फॉर्मेशन ऑफ कार्बोकेटाइन अँड इट्स रिअरेंजमेंट इज पॉसिबल. सो in case of SN1 reaction only, different product formation may takes place. SN2 reaction मध्ये डिफरंट प्रोडक्ट म्हणजे वेगवेगळे प्रोडक्ट फॉर्म होऊ शकत नाहीत का, कारण की बाय प्रोडक्ट फॉर्म व्हायला तिथे चान्सच नाही आहे. डायरेक्ट न्यूक्लिओफाईल बॅक साईडने अटॅक करणार आहे आणि फ्रंट साईडने लिव्हिंग ग्रुप बाहेर पडणार आहे. बट इन केस ऑफ SN1 रिॲक्शन मेनी प्रोडक्ट फॉर्मेशन टेक्स प्लेस, मीन्स बाय प्रोडक्ट फॉर्मेशन टेक्स प्लेस. सपोज आपल्याकडे एखादाच प्रोडक्ट आपल्याला जर इम्पॉर्टंट प्रोडक्ट आहे तर SN1 रिॲक्शनमध्ये जास्त प्रोडक्ट फॉर्म होतात का, बिकॉज ऑफ रिअरेंजमेंट. So rearrangement is there, because of that byproduct formation takes place. So this is one also important condition about SN1 reaction, that is byproduct formation, or many products are formed because of the stability of carbocation. Carbocation always try to become stabilized, and because of it will give you a formation of byproduct. Now in case of SN2 reaction, it is not possible. So you can easily identify the reaction is SN1 or SN2. Now the more important next point is about substitution at bridgehead carbon. Bridgehead carbon means, suppose there is a condition, see this type of condition is there, we have this compound and at this carbon bridgehead म्हणजे जेव्हा दोन रिंग्स एकमेकाला जिथे अटॅच होतात त्याला म्हणायचं ब्रिज होतं. इथे ब्रिज फॉर्मेशन होतं. ही जी एक रिंग आहे ही काय करते, ब्रिज फॉर्म करते, आणि ह्या कार्बनला काय म्हणायचं, ब्रिज हेड कार्बन. सो जर ब्रिज हेड कार्बनवरती न्यूक्लिओफाईल असेल, लिव्हिंग ग्रुप असेल, तर याची रिॲक्शन पॉसिबल, द रिॲक्शन ऑफ दिस इज नॉट पॉसिबल. नो रिॲक्शन विल बी देअर. नो रिॲक्शन विल बी देअर. वाय? बिकॉज सी, इन केस ऑफ SN1 रिॲक्शन देर इज अ फॉर्मेशन ऑफ कार्बोकेटाइन टेक्स प्लेस, राईट. फर्स्ट स्टेप विल बी फॉर्मेशन ऑफ कार्बोकेटाइन आफ्टर लिव्हिंग ऑफ दिस Cl मायनस. मग हा जो कार्बोकेटाइन फॉर्म होणार आहे तो कार्बोकेटाइन फॉर्म झाला. कार्बोकेटाइनची ही बेसिक कन्सेप्ट काय की इट इज अ प्लेनार स्पेसिस. It is a planar species having positive charge, but now we are getting this carbocation, it will be not a planar. तो जर planar नसेल तो stabilize नसणार आहे, right? So in case of bridgehead carbon, no reaction is possible. SN1 reaction पण possible नसते आणि SN2 reaction पण possible नसते. But if there is a longer chain, म्हणजे जर bridgehead carbon आहे तिथे longer chain formation असेल, then you can get a different product. Suppose this type of cell 222 octal, 222 octal, then you will get a there is a chance for the substitution reaction, means SN1 reaction may be possible. So you can say it is a tertiary bromo bicyclo 222 octal. Okay, so this will give you the little bit chance for the substitution reaction in case of SN1 reaction. But mostly in case of bridgehead carbon, nucleophilic substitution reaction are not possible. Okay, make this point in case of bridgehead carbon SN1 reaction is not possible. So this is all about SN1 reaction. Up to now we have discussed about normal reaction of SN1. SN1 reaction is two-step reaction. First step is formation of carbocation. Second step is nucleophilic attack. So in case of first step, as it is a slow step, it is a rate determining step, and second step is a fast step, which is the attack of nucleophile. So as only rate is depend on concentration of substrate, we can say it is a first order reaction, right? It is a first order reaction. So in case of stereochemistry, in case of carbocation, mostly racemic mixture formation takes place, because in first step as carbocation formation, in second step attack of nucleophile from both backside as well as front side is possible. So it will give you racemic mixture, inversion as well as retention of configuration is there. But in case of this, if there is a formation of carbocation, more stable carbocation is formed, then it will give you both retention and inversion. So it will give you 98% racemic mixture that we studied about benzylic carbocation with example of benzylic carbocation. And if there is a carbocation is not that much stable, then it will give you 34% racemization, means minimum racemization, and mostly inversion of configuration, means backside attack is preferable. This is about stereochemistry. In case of that, one more point that about solvent. If the more nucleophilic solvent is there, more nucleophilic solvent means backside attack is preferable, means inversion of configuration 80%. And if there is a nucleophilic compound is in less concentration, then it will give you 90% racemization, means racemization will be preferable, not backside attack of nucleophile. So we studied about this